9. That's what I was thinking to do. 5 and 3. Okay. And 6. So,
and number 1 and 4.
So for number 5, what's changed here? Y'all don't need this one? The back. Well, they're going to do a little more. I don't want to confuse you. I mean, you could put a password on it. Okay, number 1. 5 cosine 4x. That means my amplitude is what? 5. And my period is, okay, so it's 2 pi divided by 4, which is pi over 2. Yes? All right. Is everybody with me? Okay. So that means I'm going to take the cosine graph. My high and low is going to be 5 and negative 5. Those are going to make 100 on this. And that means that my entire period, my 0 up, 0 down, 0, has got to happen in between 0 and pi over 2, right? Say right, because that's right. Okay. I think your units go to like quarter pies, is that right? 1, there's a half pi. Right? It's marked whole pies, but it goes by yeah. Okay. Oh, thank the Lord. I'm about to die. It feels like 91. My brow is sweating. Okay. Y'all need to eat a piece of chicken or something. Y'all not getting enough calories in your diet. Okay. I don't know what that means. Okay. So I don't have any asymptotes on this. I'm putting this on here, but this is not an asymptote, okay? That's just to remind me where my graph is it has to end back up. What is the cosine of 0? Oh my gosh, don't just guess numbers. No, the cosine of 0, it's 1. All right, listen, y'all asked how do you know what to do and where to start and everything else. So I always start by asking myself, what's the cosine of 0? Am I starting up at the amplitude or am I starting at 0? I'm going up to the amplitude on this one. 2, 3, 4. I mean, I can print you one if you want to. The cosine of 0 is 1. All right, so we need this or no? All right, the cosine of 0 is 1, so I'm going up to the amplitude. So at the end of the period, I'm going to end where I started. I always end where I started. Everything you do when you go a period, you always end where you started. That's the definition of period. It does a complete cycle. Okay? All right, now, halfway between, if you think about a cosine graph, if cosine does this, what happens halfway in between two highs? It's a low, right? So halfway between is going to be my low. That's going to be down to 5. Halfway between each of these is where it hits the axis. That's exactly right. And I could continue with this if I needed to, continuing now that I've got the pattern because it's going to hit in between each dash mark. But I only need one period, and there it is. All right, which other one? Okay, I'm fixing to show you. That's why I didn't give you, we have skipped over the hard ones. We're not doing translations. We're just doing these amplitudes and period changes, yes. They have different standards that it's not always related to calculus. Like, it's not always, I don't know. All right. Now, first things first. Whenever y'all are ready, let me know. We'll wait. That's okay. I'll still give them the same homework sheet. So. All right. First of all, remember what my cosecant graph looks like, or my cosecant and my sine. I got to decide which one this one's going to be, but I got my cosecant and my secant. So I need to know, am I having a point on the x-axis, or is that an asymptote at the x-axis? So my question is, what's the sine of 0? 0, right? If the sine is 0 at 0, that's going to put me in undefined territory, which means I'm starting with an asymptote. That's how I know. Cosecant always starts with an asymptote on 0. And if you haven't shifted it anywhere, that asymptote is still going to be there. Okay, what is, now it doesn't have an amplitude, but it kind of does have an amplitude. What's it going up and down to before it shoots up and shoots down? 3/2, which is 1.5 or 1.5, right? What is my period here? But none. Undefined, none. Yep. It's just pi. It's still 2 pi over that b, so it's just pi. Okay, so that's right, because remember, what you start with and what you end with are the same thing throughout an entire period. All right, so 1, here's a half pi. 2, there's a whole pi. So here is my other asymptote, yes? All right, that's a complete period, though. And think about the way these look. These are a little bit different than my other. I got to go up, down, right? That's what my graph looks like. So over here, what's happening if I pick an entire period? This is an entire period, yes? Halfway in between, what happens? An asymptote. And halfway in between that is my up and my down. What am I going up to again? 1.5 and down to 1.5. So halfway in between is up to 1.5. There's that piece. Halfway in between is down 1.5, and there's that piece. One complete period is your minimum. Because that's the way the period works on secant and cosecant. One complete period is going to consist of 3 asymptotes. All right, number 4. What? Secant graph. Okay, yes, and it's a little bit harder, but I'll show you. But this one also flips. So this one's got 2 things going on. One, my amplitude, which is not really my amplitude, but still it's 2, right? So amplitude's undefined. My period is still 2 pi, but things are different here. And things are different because my highs become my lows and my lows become my highs. So if this is 1 over cosine, what's the cosine of 0? 1, right? So this is going to be, you would think, a high point, but because of this negative, it's actually a low point. Does that make sense? Right. Thank you. Listen now. Listen now. Half a pie, a whole pie, 1.5 pies, 2 pies. I'm going to end up back over here, yes? All right. That's a whole period. Split in half. What happens between 2 lows on a secant graph? Or a cosecant, it doesn't really matter. Between 2 highs or 2 lows or whatever, what happens? A low, that's right, a low. So halfway in between, so at pi, but instead of a low, remember everything's split. My lows are highs and highs are lows. So it's going to be up to 2. Between these are asymptotes. That's exactly right. So asymptote, asymptote. Now, did you have to do your period there? No, you could have done, I mean, you could keep going with it so it looks a little more familiar to you, right? And then you would slowly but surely get the picture, but you don't have to do that many. What else? 5. Cotangent we don't do quite as much with like we do with the others, and mainly because of our time restraints here. But I'm not going to worry about the stretch or the shrink on the front. I am going to worry about the period. Period being 2 pi divided by a half, which would be, what does that give you? Oh, it is just pi, sorry. Sorry, brain's getting ahead. Well, 2 pi divided by a half would be 2 pi times, not 2 pi. Pi divided by a half would be pi times 2 over 1, which is 2 pi. It is. So instead of, what did I do? Oh, I see what y'all are right. I'm wrong. Y'all are right. Pi over b, not pi over a. I'm losing my mind. Okay, so a quarter, here's a half pi. So my whole period needs to happen in that area right there. The question is, are the asymptotes straddling the y-axis, or are the asymptotes starting at 0 and going on? This is cotangent. So what happens with regular tangent? Let's look at it this way. Cotangent is cosine over sine, agree or disagree? What is the sine of 0? Is it a value or is it an asymptote? I mean, it's an asymptote because the sine of 0 is 0, which means my asymptote is happening here. Go over 1 complete period, and that's where your other asymptote is. Yes. It's all slid over, yep. And it goes the opposite direction of tangent. Say again? Yes. There it is. That was the thing. Up to what? Okay, we'll do that in a minute. I think the reason this gets hard is because these fractions, and look at this period now on this one. 3 pi over 2. Yeah. No, for 5. No, for which one am I on? It's 5. We just did that. How do you know? What secant is the flip of what? No, cosine. What's the cosine of 0? 1. So there's a point there, right? And that, because I'm looking at what's the cosine. If it's 0, there's going to be an asymptote, because this is 1 over cosine. If it's 0, there's going to be an asymptote. If it's not 0, it's going to be my high or my low point. Yes. Now, I'm going to find my period. There's a half a pi. There's pi. There's 3 pi over 2, right? So this is another high point. High point is a loose term because it's actually opening up, but still. So now halfway in between two highs, what happens? A low. Well, what's halfway in between? I'm probably just counting these tick marks. 1, 2, 3, 4, 5, 6. So if I go over 1, 2, 3, and then I go down to my low, right? Say right. Okay. And then halfway in between there is where my asymptotes are going to happen. So 1.5 over 1.5 over, yeah. There you go. And if you want to continue these on, you certainly may. Just 6. Two pi over, that's not a co-function, that's just cosine. It's just your basic cosine that's got an amp of 2 and a period of 4 pi. What's the cosine of 0? 1. So when you start at 0, you start at your high or your low. You always start with the high unless you got a negative in front, which makes you start with your low. Your asymptotes, you don't have asymptotes on cosine or sine. Only on secant, cosecant, and cotangent. So for secant, that's 1 over cosine. So when cosine is 0, you got an asymptote. The bottom can't be 0. That's the 1 over cosine. All right. How might you find this? Exact values only. All right, let's work. Understand this is asking you to take the inverse cosine of this value. So let's talk through it. What's the secant of pi? 1 over cosine, right? We know that secant is 1 over cosine. So what's the cosine of pi? -1. So the secant, right? So cosine of pi is -1. We all agree? Oh, this is still just more trig function, inverse trig function. Well, I don't have time to run you through those other two graphs now, so I'm just doing the analytical part of it. We'll do it tomorrow. Huh? Arc cosine is the same thing as inverse cosine. All right, so if cosine is cosine of pi is -1, then the secant of pi is -1. Do you agree? So now if I ask you, well, because secant is 1 over cosine, so this would be 1 over cosine pi, right? So how do I evaluate this now? What does this mean? Flipping what? What does it mean? And we did this back in the beginning. No, not quite. When I ask you for the inverse trig function of something, what am I really asking? Not, okay, so if I ask you secant pi or cosine pi, I say go to pi and tell me what the value is there, right? But if I say inverse cosine of -1, what I'm really saying, probably a good thing we're reviewing, is I'm saying where is cosine equal to -1 on your unit circle? Remember when we were solving those triangles and we said sometimes you might have something like sine x equals 2/3 and you had to do the inverse on both sides kind of thing? It does undo itself, but that makes sense, right? Because cosine and secant, inverse cosine and 1 over, okay, so, but anyway, it doesn't matter. Where is cosine -1 on your unit circle at pi? Yes. What's what? Sine x 2 over. I was just saying if you were doing, remember we saw those triangles? Well, no. I'll give you a blank one you can fill out if you want to jot some down. It probably won't be worth anything. I'll just give it to you as an aid if you want to do it to help yourself. Look at this one. Inside out. We're gonna work inside out. Don't say it yet. Don't say it yet. Yes, you do, Emery. Okay, first off, let's work inside. What is the cotangent of pi over 4? So if you're on your unit circle, right, it's one. Yeah, that's a different question. Are you done with that? So it's inverse sine of 1, or arc sine. If you see that, it means the same thing. So where is sine 1? Don't be ugly. Don't hate him because you ain't him. I know you can. Which one? Oh. Cotangent is the flip of tangent. So what is the tangent? If you go to pi over 4 on your unit circle, what's the tangent at pi over 4? 1. So if you flip that over, what do you get? 1. So this becomes 1. So if you see a trig -1, it's literally saying, where does that value occur? Whoa. Whoa, Nelly. Yeah. At pi over 2, the cosine is 0. So where is tan 0? Where? Okay, so, but this is where I get into. What did y'all say it was? We have to, that's where, right? No, wait. We got to restrict the domain. It's going to be 0 because it's here, cosine x. No, it's undefined. No, it's 0. It's 0. It's 0. It's 0. It's 0. It's 0. Yeah, no, this is right. The reason, and I don't have time, yes, I don't have time to go over the inverse trig functions, but remember that sign one where we had to restrict the domain? The domain of tangent is sandwiched between pi over 2 and not actually, pi over 2. So we have to stay up here with any tangent value, is why. Yep. You're going to have a couple of questions on here where you have to form a triangle. And let me just show you this really quickly. If you talk about, and you should have had this in geometry, but I'm not going to make any assumptions that you did. If you see something that says it's an angle of elevation, that means from wherever you're standing, you shoot like a laser out of your eye and you look up. This is your angle of elevation right here. No, that's theta. That just means a degree, an angle measure. And if you are talking about an angle of depression, that's again with the laser straight out your eyes and you're looking down. That's your angle there. Okay. So, and they always form right triangles. If you look at this one, here's your right triangle. If you look at this one, here's your right triangle. So you're going to set these triangles up. And they're going to be missing the theta, but you're going to have to solve it. So you might do something, you're going to get into your SOHCAHTOA. You might say something like the sine of theta is 5 over 17. Write an expression for theta. Well, what would you do? We talked about this before. Y'all can do this. The sine of theta equals 5 over 17. What does theta equal? Remember how we talked about like the inverse will cancel out kind of thing? Not on your unit circle. I'm just pulling random numbers on solving. And that makes your inverse sign. So if you were using a calculator, you could just hit second sign. If you did not have a calculator, we're using unit circle. If that was on your unit circle, where does the sign equal 5 over 17?